Good day, I'm Joseph Margarico, together with my group mates, Cadiz and Bar. For today's, we will going to discuss about PCB designing and soldering. First is, what is printed circuit board? A printed circuit board, or PCB, mechanically support and electrically connect electronic components using conductive tracks, pads, and other features, etc. from the one more sheet layers of the copper laminated on the or between sheet layer non-conductive substrate. So PCB, well, basically a printed circuit board, or also known as PCB, is the one of mechanically supported electrical connects electronic components using tracks such as printers, mobile phones, and some of electronic devices. So a printed circuit board is ayun yung sa mga sa mga smartwatch, computer, and etc. So we can classify into three different group. So the first one is the single-sided. Well, the single-sided PCB is also known as the most common printed circuit board and produced since it was very simple and easy to make. So yung sa may single-sided, so ayun lang yung isang part, parang isang part lang siya, hindi siya dalawa kasi single nga, di ba? So yung example ng single-sided PCB is the camera system, radio component, and calculators. The next one is the double-sided PCB. Well, the double-sided PCB, which is known as the gateway to higher technology application, where it's become famous due to it allows for more routing traces by alternating between a top and bottom layer. So yung sa may double-sided PCB, ayun yung back-to-back na siya na ayun yung back-to-back na side na siya na may design. Di katulad dun sa may sa single-sided, yung isang side lang yung meron siyang design. So yung example of double-sided PCB is the power supply, phone system, and automotive dashboard. So the last one is the multi-layer allow to higher component density. So dito sa may sa may multi-layer PCB is which is known as having a higher speed and operating capacity that is often necessary for advanced device such as, so yung mga sample lang ng multi-layer PCB is the computer, data server, and satellite. The next one is what are the different ways to make a circuit printed board? So the first one is the iron and glossy paper method. So dun sa may sa first one is yung paper method is ginagamitan siya ng iron glossy paper para makapagawa ng PCB design, or parang nakaprint na po siya, then ang gagawin is i-iron siya para gamit yung glossy paper method. Next is the circuit by hand or PCB. Dito sa circuit by hand or PCB, parang mano-mano siyang ginagawa. Next one is the laser cutting or edge etching. So yung laser cutting, edge etching, ayun yung parang nile-laser yung bawat dulo ng ng design ng PCB. Para sa akin, ayun yung pinakamadali kasi naka-ready na siya, tapos i-laser na lang po siya. So dun naman sa may PCB design, it is usually done by converting your circuit systematic diagram into PCB layout using PCB layout software. So dito sa PCB design, yung parang kino-convert mo na yung mismong PCB design mo, or nilalagyan mo na siya yung mismong diagram into PCB layout using software. So what are the materials in making printed circuit board or the circuit board? First is the magazine or advertising brochure. Next is the laser printer. Next is the household iron clothes. Next is the copper plate laminate and etching solution, kitchen scrub, thinner or acetone, Fect 13 powder solution, photo glossy paper, permanent marker, sandpaper, blade cutter.
Proceed to the step of making PCB. Step 1 is take a printout of circuit board layout. A printout of your PCB layout using laser printer and A4 photo paper glossy paper. Keep in mind the following points. First, you should take the mirror printout. Second, select the output in black both from the PCB design software and the printer driver setting. And third, make sure that the printout is made on the glossy side of the paper. Step 2. Cut the copper plate for the circuit board. Cut the copper board according to the size of the layout using the hacksaw or a cutter. Next, rub the copper side of the PCB using steel wool or abrasive sponge scrubs. This removes the top oxide layer of copper as well as the photoresist layer. Sanded surface also allow the image from the paper to stick better. 3. Transfer the PCB print onto the copper plate. Step 3 has two methods. First one method is iron on glossy paper method for complex circuits. Transfer the printed image taken from a laser printer from the photo paper to the board. Make sure to flip top layer horizontally. Put the copper surface of the board on the printed layout. Ensure that the board is aligned correctly along the borders of the printed layout and use tape to hold the board and the printed paper in the correct position. 2. Circuit by hand on PCB for simple and small circuit. Using the circuit as a reference, draw a basic sketch on the copper plate with a pencil. Once your sketch looks good, trace over it with a permanent black marker. Iron the circuit from the paper onto the PCB plate. After printing a glossy paper, we iron its image side down to the copper side. Then heat up the electric iron to the maximum temperature. Put the board and photo paper arrangement on a clean wooden table. Cover with a tablecloth with the back of the photo paper facing you. Using plier or a spatula, hold one end and keep it steady. Then put the hot iron on the other end for about 10 seconds. Now, iron the photo paper all along using the tip while applying a little pressure for about 5 to 15 minutes. Pay attention to the edge of the board. You need to apply pressure and do the ironing slowly. Doing a low hard press seems to work better than moving the iron around. The heat from the iron transferred the ink printed on the glossy paper to the copper plate. Next, caution, do not directly touch copper plate. It will be very hot from the iron. After ironing, place the printed plate lukewarm water for about 10 minutes. The paper will dissolve. Then you can remove the paper gently. Remove the paper by peeling it from a low angle. In some cases, when removing the paper, some of the tracks get painted. In the figure side, you can see that the track is light in color. Hence, we can use a black marker to darken it as shown. Etch the plate. You need to be really careful while performing this step. First, put a rubber or plastic gloves. Second, place some newspaper on the bottom so that the etching solution does not spoil your floor. Third, take a plastic box and fill it up with some water. Next, dissolve 2 to 3 teaspoons of ferric chloride powder in the water. Next, dip the PCB into the etching solution, ferric chloride solution or PC13 for approximately 30 minutes. The PEC13 reacts with the unmasked copper and remove the unwanted copper from the PCB. This process is called etching. Using a plier to take out the PCB and check if the entire unmasked area has been etched or not. In case it is not etched, leave it in the solution for some more time. Step 6. Cleaning, disposal, and the final touches for the circuit board. Be careful while disposing of the etching solution. It's toxic to fish and other water-based organisms. Don't even think about pouring it in the sink when you are done. It is illegal and might damage your pipes. Instead, dilute the etching solution and then throw it away somewhere safe. A few drops of thinner nail polish remover work well. On a pinch of cotton wool will remove completely the toner ink on the plate, exposing the copper surface. Rinse carefully and dry with a clean cloth or kitchen paper. Trim to final size and smoothen edge with sandpaper. Now, drill holes using a PCB driller like this PCB driller and solder all your cool components to the board. If you want that traditional green PCB look, apply solder resistant paint on the PCB lacquer. And finally, your super cool circuit board will be ready.
Topic we are discussing about soldering. Soldering is the key in many industries including electronics where it enables both electrical conductive and some mechanical strength. It is the material that melts around the joints and solidify to provide mechanical rigidity and electric conductivity. Origin of soldering. The concept of soldering has been known for very many years. Some silver solder joints have been found on items dating back on between 3000 and 200 BC. More recently, soldering development in the 19th century for various craft uses, and then with the advent of radio and later electronics around the beginning of the 20th century, it came into its own. Soldering is a process in which two or more metal items that are joined together by melting and then flowing a filler metal into a joint, the filler metal having a relative low melting joint. Soldering is used to form a permanent connection between electrical component. The metal to be soldered is heated with a soldering iron, and then solder is melted into the connection. Materials that are needed in soldering. First is the soldering iron. A soldering iron is used to heat the connection to be soldered. For electronic circuit, you should use a 25 to 40 watts soldering iron. Higher wattage soldering irons are not necessarily hotter. They are just able to heat larger components. A 40 watts soldering iron makes joints faster than a 25 watts soldering iron does. A soldering iron can be purchased at hardware stores and at most large development stores. Then next is the rosin core solder. Solder has a lower melting point than the metals that are being connected do. The solder it is heated by the soldering iron, but the metals being joined will not melt. Rosin core acts as a flux. It prevents oxidation of the metal that are being connected and enhance the ability of the solder to wet the surface that are being joined. Then, solder that is used to join copper pipes has an acid core, which is appropriate for pipes but will corrode electronic connection. Use solder that has a rosin core. This is the stand on hot soldering iron. There are a variety of stands available. It is important to always keep the hot iron in its stand when not in use. Next is the sponge. The damp sponge is used to clean the tip of the soldering iron. Is the solder braid. This is used to remove solder. To use the braid, place it over the solder to be removed and heat it from above with the iron. Prototype boards have copper tracks on pads for connecting components. Next is the steel wools. or fine sandpaper. This is used to clean connection prior to soldering. Solder will not flow over a dirty connection. Next, the crocodile clips. These can be used as heat sinks if needed.
And now we are going to proceed on how to solder. We have 4 steps that we will discuss. Step 1. Mount the component. Begin by inserting the leads of the LED into the holes of the circuit board. Flip the board over and bend the LEDs outward at a 45 angle. This will help the component make a better connection with the copper pads and prevent it from falling out while soldering. Step 2. Heat the joint. Turn your soldering iron on, and if it has an adjustable control, set it to 400 Celsius. At this point, touch the tip of the iron to copper pad and the resistor leads at the same time. You need to hold the soldering iron in the place of 3 to 4 seconds in order to hit the pad and the leads.
Apply the solder joints. Continue holding the soldering iron on the copper pad and the lead and touch your solder at the joint. Snip the leads. Remove the soldering iron and let the solder cool down naturally. Don't blow on the solder as this will cause a bad joint. Once cool, you can snip the extra wire from leads. A proper solder joint is smooth, shiny, and looks like a volcano or cone shape. You want just enough solder to cover the entire joints, but not too much so it comes a ball or spills to a nearby leads or joints. So all for our topic. Thank you for listening.